Hello, my name is Dermot Karen with Qnect. Our webinar today outlines 3 significant steps to improve fabrication production. I'm here to introduce 2 gentlemen with our company. The first is Henry Letterman, who is one of the co-founders of Qnect and the CSO. He brings to the table over 4 decades of experience in the steel industry. I'm happy to have him here today to answer your questions. I also have with me Josh Hines, who manages the technical field support. Josh has experienced a multitude of positions in the steel industry for over 2 decades, including steel detailing, project management, and even hanging the beams in the field. Today with Josh, he will outline the 3 significant steps to improve fabrication production. With no further ado, Mr. Josh Hines.
Thanks, Dermot. As Dermot said, here's what we're going to cover today. Shop drawing production, preventing schedule drift. One-station fabrication for plant flow and efficiency. Reducing time to fabricate 20 to 50% fewer bolts and holes. So first, let's do a refresher on how the system works for those of you that do not know. All right, so first we're going to look at the Qnect web-based application where we set up all of our preferences prior to running. So there are locations for connection types in hierarchy as well for vertical shear and shear and axial. Same thing with forces. There's none shown here, so that means that they are being overridden in the model. We can also fill out a table with any profile or multiple profile in one, with the vertical shear as well as minimum rows. Same thing with the UDL factor, uniformly distributed load factor, and short span members for any profile size desired. Same with lrfd or ASD. And then I'll just quickly show down at the bottom here of our minimum job requirements, the minimums and maximums of material, preferences set up for stabilizer plates, as well as material grade, so on and so forth. So let's jump into the model. So first and foremost, where is our Qnect button? Actually right here, 1, 2, 3 button system under the steel ribbon. If it does not appear there, depending on the environment that you have with your licensing, you can find it in your macros. So let's do a full run on this project, except for one beam, and I'll show you the reason for that after. So right now what I'm doing is I'm going to create a session, and this session is going to be just a placeholder for reporting information, and it's sending information up to our cloud-based system, and the preferences that I just showed you very quickly, it's meeting that in our system. It's then crunching through, creating the connections themselves physically, and also the calculations so they can be brought back into the model. As soon as it's done, you'll receive an email telling you how many connections were done and how long it did take. So let's go to button 2. We can see that it's already back. I'll go ahead and say submit. So now it's importing information into our user-defined fields, as well as bringing in the actual connection components and calculations. As you can see, all the cut planes, those have come in. Let me clean it up a little bit. Now let's look at a calculation on one of these connections. So we simply double click, go into the component. You'll see all the information associated to this member. I won't bother you with that right now. But then if you select the link here, it's going to take you to the full calc information. You have your main calc, your bolt strength, bolt bearing. You have your beam strength, and you have your shear plate, as well as the weld calculation information. Okay, so let's go back into the model, and let's go back to this joint that we didn't connect. So the reason for that is we know in production of a model that we continue forward. We don't just stop and then place all the connections and that's it. So if I turn everything else on, you're going to see a project that looks very similar to something like this, where you have your pour stop, you've got studs, things like that, column splices, base plates, so on and so forth. So I wanted to make sure that everybody realizes that, just because it's not a stick model doesn't mean we can't connect it. So it's still going to be a manageable process, and let's see what that does for us. speed is one of our biggest things here, so let's go ahead and bring this in since we know it should already be done. There we go. And it looks like there were a couple skewed connections, probably because they were a little close to some of these areas, and that's why they didn't go. So we'll do that in kind of a vetting process to bring the remaining in. And then again, speed is definitely our friend, so we'll go after these one more time. There we go. All right, so now we're going to discuss preventing scheduled drift. We'll come back to the model after. All right, so preventing scheduled drift. Everyone experiences changes that cause the schedule to drift, and you end up scrambling in the shop very inefficiently. So the model I just did took less than a minute to not only run and calculate, but to bring everything back into the model, and we can start evaluating things very quickly. So some context, 4,300 ton project, engineered and modeled joints in 35 minutes, buffer of 5 weeks. We're also working on 3 60-plus story high-rises right now. 15 joints in 2.5 hours gives us a buffer of about 8 to 10 weeks. And size, small, large, doesn't really matter for us. It's all relevant. This will also apply to your estimating phase if you desire. So now we have this buffer, right? So how can we continue to prevent drift when changes come in? I think you can already imagine that any change can be done within minutes or hours. Expediting changes helps prevent scheduled drift. So we're going to go back into the model and look at a change. Okay, so let's do a quick change. So we're going to come in and we're going to upsize this to an 1835. And let's also say that this is 40 kips total, both sides. Now, as soon as I modify that, we're going to re-engineer it. It's going to go back up to our cloud-based system. Then it's going to come back down and automatically populate when I end up re-engineering. So you'll notice those connections have been stripped out of there, and the new ones will be placed back in. Fully modeled, fully calculated, everything's there. All right, so now let's talk about one-station fabrication. So in one-station fabrication, the goal here is to keep pieces off the plant floor or any time that you have handling out to the yard, coming back, or from skid to skid, it's just not needed. So using our patented software and proprietary process, Qnect will manage the end connections to maximize the number of pieces that go through one-station fabrication. So what does that really mean, and what does that really mean to you? Well, let's look at this member here. So in the shop, you're going to have bolted ends here, so no welding, right? But on this member, you're going to have shear plates that are welded. So really what we can do is let's just do everything bolted so we don't have to worry about going anywhere else. It gets bolted and it's done. So let's do that. Let's do a single angle, bolted at all these locations and see what that gives us. So what the goal here is, if you're going to be able to do bolted in an entire location, or if you're going to be able to do welded in an entire location, so you can maximize the efficiency. So you can see that these came in as bolted. So now, whether you have equipment or maybe you don't have equipment, but now all of your bolts, all of your holes have been taken care of either manually or by your equipment. And now the only thing you have to do is physically come in and bolt these up, and you do not have any welding. All right, so now let's get into reducing time to fabricate. So let's go ahead and optimize a joint. We can see right here, this is a double angle connection, okay? And there are there are 6 bolts, okay, 6 rows of bolts. So let's go ahead and let's make this more efficient. We're going to bring in bolt optimization. We're going to reduce the quantity of bolts, and at the same time, we're also going to adjust the vertical spacing by doing so. So we're going to bring this back in. All right, so we went from 6 rows to 4 rows. Okay, so now we have 6 less bolts overall. So that means 6 bolts we don't have to order. Okay, that also means 2 fewer bolts in the shop to install, as well as 4 bolts fewer to install in the field. So 12 holes less to drill, cut, or punch on one connection. So 33% of that connection with the bolts is just gone. So what does that really mean to you? The last thing I want to touch on here is typically we see a reduction of bolts of 1 to 1.5 bolts per ton. So if you have a 1,000-ton project, you could see about 1,000 to 1,500 fewer bolts, and of course 2 to 3,000 fewer holes to drill, punch, or cut. Add that up job after job, and the results are very impressive. Now let's get into workflow. So who does all this work in your project workflow, getting the Qnect connections into a model? Well, I'm pleased to say that Qnect will take a checked model if you want us to manage that process. So we can manage the in connections to maximize one station fabrication. We can also optimize your connections with bolt optimization, so on and so forth, if that's what you're looking for. And then time frame to go along with that. Typically, we're 24 to 48 hours on our turnaround, and there's 2 ways that this can be done. One is if your detailer is able to take a break within 24 to 48 hours, send the model to us. We will then place everything in, and we will send it back. Or the preferred method is the shared model environment. So that concludes everything for the webinar. Thank you very much for all of your time. I'm going to send you over to Dermot.
Thank you so much, Josh. And now for questions and answers with Henry Letterman. Henry, the first question is, how do you do one station fabrication? What is your process?
Thank you, Dermot. It's a pleasure to be here. First, let's start with that the process we use is proprietary along with a patented software. But the fundamental nature of it is iterative as we look at a change in the type of attachment within a girder measured against the ends while designing all of those within a short period of time. We do that within the resources of the client, meaning what is their preferred connection type, what's their second preference, third preference, what percentage of welding versus bolting. So we collaborate with them, and then with our process and software, we will manage that process. Ultimately, the goal is to have the maximum number of pieces that go through the shop first without any attachments on them, and second, maximum number of pieces that go through one fabrication process, either bolting or welding, thereby reducing the number of pieces on the plant floor.
Thank you. The second question is, are connections designed with calculations? Are they able to be stamped in all 50 states?
Yes, thank you. All of our connections are fully engineered, meeting all of AISC limit states. Our connection engineers will stamp our work and finish any part that we did not do. And we can stamp in all of the states in the United States and also Canada for that matter. And Qnect is more than happy to carry the full connection design package.
Thank you, Henry. The next question is, could you confirm the safety of connections where there are different loading conditions?
All right, thank you. I'm not quite clear about this question. There's a question about safety. There's a question of loading conditions. Let me cover both. First, if by safety we're talking about OSHA, yes, we provide the allowance to create OSHA connections, beam to beam, beam to column web. We do that in a couple ways that are selected on our preferences on our website. And in terms of loading conditions, we do shear and axial, moment connection, New York City integrity, IBC codes. We'll soon have vertical bracing, all meeting the full limit states of AISC. I hope that answers the question.
Thank you, Henry. For our next question we have, can we use the information from Qnect in estimating a project?
Well, Qnect is used quite a bit in the estimating process. In fact, we are working with several fabricators, both small and large, where they're integrating us directly into the estimating process. We're building some customization to meet their specific needs, working with our field tech manager, Josh Hines. And then that seamless approach goes right into estimating through production. In terms of further workflow, Qnect is happy to build a model from scratch at $1 a ton, or if you give us a Revit or an IFC file at 50 cents a ton, we will run the job multiple times, engineering it, and we'll provide all the analytics and data and VE savings so that our clients can maximize their opportunity to win a bid.
Thank you. Our last question is, how does Qnect relate to FabTrol?
Well, again, like the previous question, we have a relationship. You know, our software is used with all of the estimating softwares, FabTrol, FabSuite, you know, whatever it is you're using, and so that's not a problem. And again, we'll work with any firm to custom a need around how they estimate. We do provide a costing structure based on units we have, but a more accurate response would be, what are the units you use?
Very good. Thank you for answering our questions, and thank you for attending our webinar.